Okay, so let's discuss some conversions related to moles. Okay, so first one is to convert given mass in grams into moles. What is the formula we have? Like number of moles equals to given mass weight by molar mass, right? We will get number of moles of that substance. Okay, next, if number of moles is given and if they are asking for weight, number of moles into molar mass gives weight of that particular substance, okay, in grams. Then next, what we discussed along with this, volume, conversion of number of moles into volumes at STP conditions, right now. And the next, number of particles, right now. So now based on this, just solve these questions. These questions tell me what is the answer for this. Number of moles in 28 grams of nitrogen atom is. So what is it? Very simple. So number of moles, given weight 28 grams. Okay, nitrogen atom they mentioned. Atom, nitrogen only. Okay, its molar mass of nitrogen atom is 14 gram per mole, right now. So this is 28, here 14 gram per mole. So that you will get 2 mole. Okay, see here there is some little confusion is there for few students. Here they mentioned nitrogen atom. Sometimes they won't mention, they will just mention 28 grams of nitrogen they will mention. They won't mention either N or N2, they will just mention nitrogen. In this case, what you need to take? N2. What is the standard state of nitrogen? It will be like this, diatomic molecular form, right now. So this you should consider. 28 grams of N2 is given if they mention nitrogen means. Now in this case, number of moles of N2 will be, nitrogen will be 28 by 28. This should be 1 mole. Okay, you got the difference here. Okay, next, for this you tell me the mass of 2 moles of nitrogen atoms is same, reverse of this, right now. Are you able to follow this? Very simple. Okay, this I told, number of weight equals number of moles into molar mass. Very simple, right? Next, tell me for this, number of moles in 12.044 into 10 power 23 nitrogen atoms. How many moles? See, Avogadro 10 power 23. If they say this number, this is Avogadro number, we know this is 1 mole, right now. So given number is 12.044 into 10 power 23. This is how many moles? Like X moles I am saying. So X will be this one 12.044 into 10 power 23 divided by, see, multiply this 6.022 into 10 power 23, right? So this will be 2. So X will be 2 mole of nitrogen atoms are there.
If they give N2 also same value will come.
That is molecule it will be.
But same value.
No, it will be different value, no? So in one molecule how many atoms are there?
6.0.
In one molecule 2 atoms. It is a diatomic nitrogen. N2 molecule is a diatomic. So 1 mole of N2 molecule, if I say, you should say 2 moles of nitrogen atoms. Is that clear? So now if I say 1 mole N2, see, in 1 mole N2, 1 mole molecule, so 1 mole molecule you have, so 2 atomicity into number of moles. How many moles are given? 1 mole are given. This number should be called as atomicity. So atomicity into number of moles gives you how many atoms are there in the given species. Right now, this is clear? Yeah. Next. For this question you tell me, next one. How many moles, how many atoms of oxygen are there in 16 grams of oxygen? So N oxygen. So oxygen means what you should understand here? O2 it is. So you are finding NO2 will be 16 grams by 32 gram per mole. So 1 by 2 mole or 0.5 mole. Okay. So what they are asking? How many atoms of oxygen? So number of atoms equals to atomicity into number of moles of that O2 molecule into Avogadro number. Right now. So now atomicity of O2 is how much? 2. How many moles we got? 1 by 2 into Avogadro number 10 power 23. That's it. This will be your answer. So your number of atoms here will be, number of oxygen atoms are 6.022 into 10 power 23. Sometimes it will be indicated like this. Okay. So you got a half mole of oxygen molecules. Number of moles of atoms will be twice of it. So 2 into that number, that will be 1 mole or Avogadro number. Right now? Yeah. So next, what we can discuss next things are, so just tell me number of total number of atoms in 64 grams of methane is dash to Na. So you can try this. How much? So what is the first step to do? First find number of moles of methane from the given mass. 64 by 16 gram per mole. So we are going to get 4 mole. Okay. So this is 4 times. 4 moles of methane we got. Okay. Now what I want? Number of atoms, total number of atoms. So in one molecule of methane, how many atoms are there? 5. So atomicity is? Atomicity is 5. Okay, 5. So now I am asking number of, total number of atoms will be equals to, what is the formula? Atomicity number of moles into Avogadro number. That's it. So 5 into 4 into Na. So 20 Na. Is that clear? Okay. Now if I ask total number of hydrogen atoms present in the same quantity. 16 Na. Why 16 Na? Because the atomicity of hydrogens are 4. So 4 into Na should be your answer. If I ask for carbon, atomicity is 1 into total number of methanes are 4, 1 into 4 into Na. So your answer should be 4 Na. Is that clear? Next. Is this clear or not? Yeah. So next, these models are clear now. Now write a question. Total number of electrons in 0.09 grams of water. 0.09 grams of water. Just give a try for this everyone. Total number of electrons. So what is the first step?
Calculate number of moles.
First, always try to calculate number of moles. So number of moles of water is how many? 9 into 10 power minus 2 I can write this one. Okay, grams. Divided by what is the molar mass of
18.
18 gram per mole. Okay, so 18 gram per mole. Okay, next this will be 2 times. Okay, so you got 1 by 2 into 10 power minus 2 means I can write 5 into 10 power minus 3 mole. Can I write it like this or not? Is that clear why I am writing like that?
Yes.
So 1 by 2 is there, 1 by 2 is 0.5. So 0.5 into 10 power minus 2. So 5 into 10 power minus 3. Okay? Okay, next. What I am asking for you? Total number of electrons. So we got 5 into 10 power minus 3 moles. Okay? So in one molecule of water, how many electrons are there?
18.
So
Sorry.
how many electrons are there? Oxygen atomic number is 8. So 8 electrons will be there, and hydrogen atomic number is 1. So 2 are there, 2 into 1 plus 8. So 10 electrons are there total, right now. So total number of electrons will become now what? Total number of electrons in water is equals to what I should say? Like instead of saying atomicity now, you should say total number of electrons in one molecule of water. So in one molecule water it is 10 into number of moles of water we have is 5 into 10 power minus 3. 1 mole contains Avogadro number now. Avogadro number of particles means Na you can write right now. So what you are going to get here? 5 into 10 power minus 2 into Na. This should be your answer.
3.3.
So if they ask you in the numbers, so you can just put it as 6.022 into 10 power 23. Here it is 5 into 10 power minus 2. So what you can say here?
Minus 2, 20.
So 5 6 are 30 into 10 power minus 2 10 power 23. So look at here, I can write this as 3 into, this is 30 now, so this is 3 into 10 power 1. Okay, so 24, it will be minus 2, 22. So 10 power 22 electrons, total electrons. Okay, like this. Okay, clear now? Next. Okay, find for this. Whatever we did previously, same application here also. Fast, fast.
Na by 2.
How many molecules of water are present in 9 grams?
Na by 2.
Na by 2. Okay, so how we got this? Number of moles of water first. Okay, 9 by 18. So half mole. So half mole na. So you can say number of molecules they are asking na. So molecules will be in 1 mole it will be Na. In half mole, half into Na.
Na by 2.
So Na by 2 you can say, or you can say this as 1 by 2 into 6.022 into 10 power 23 means 3.011 into 10 power 23 molecules are there. Okay. Next, tell me for this.
Sir, to find total number of atoms, we take an atomic
Total number of?
atoms.
I'm not getting.
To find total number of atoms, we take an atomic.
Yes.
Then why not in molecule?
Because you are considering whole molecule.
See what I am saying. What is the question? Number of molecules in 9 grams of water. So water, what is this? It is a molecule, no? So you are getting already number of moles of water. Means you are already getting molecule. If I ask atoms in this case, you should do the atomicity. This is itself a molecule. Now you are doing for molecule only. Okay. So you are taking 9 by 18. What you are getting? Number of moles of water molecules. What you are saying? Water molecules only. No? So what is the confusion here? Half Ne. If I ask for atoms, what you should do? So number of atoms if I ask, what you should do? 3 atoms are there here. So atomicity is 3 into 1 by 2 into Na. This should be your answer. Okay. Next. So now one more thing also we discussed. Volume of a gas given along with the temperature and pressure, the number of moles will be. Using ideal gas equation, we can use this formula. PV equals to nRT. From this, I am saying N equals to PV by RT. Okay, this is a simple one. Next, what do we mean by this R here? Universal gas constant. It is something like 0 liter atm per mole per Kelvin. Okay. Next. So here 1 mole of any gas at an NTP occupies how much volume? So 1 mole of any gas at STP occupies how much volume? 4 liters. So these two values are very, very important. It is experimentally observed that. So we can also say this as Avogadro's hypothesis. So what he told? 1 mole of any gas. 1 mole of
Any gas at 0 degrees.
any gas at 0 degrees and 1 atm pressure. So I am taking, so the volume occupied will be 22.4. See, pressure and temperature is specified here. Okay. So at this time the volume occupied is this much. If pressure and temperature or any of this is changed, the volume occupied by gas also changes. See here, by small little change, here 1 atm 1 bar, by little change the volume occupied also changed. Okay. So remember these two values while doing the numerical. These are very, very important. Okay. So now if I say 1 mole of methane gas I am giving, 1 mole methane at STP occupies how much volume? Occupies dash volume. Tell me how much volume it will occupies. Nothing to calculate here. I am saying 1 mole of any gas occupies how much? So 22.4 liters should be your answer. Okay. Now instead of saying 1 mole, I can also say this is 16 grams of methane. Can I say it like that or not? So 1 mole is nothing but 16 grams of methane only, right? Okay. Now I am changing this little bit. Okay. So now tell me one more thing. Now instead of saying 16 grams, I am giving you 4 grams of methane at STP occupies how much volume? Dash volume. So tell me what is this value? How much I given? 14 grams. So how do you do this?
14 grams, 4 grams.
4 grams.
Now first calculate number of moles.
Calculate. Just a minute. This is.
1 by 4. 22.4 by 4.
Huh. So tell me, how much? 16 grams means 1 mole. 1 mole means 22.4 liter. Okay. So 4 grams means how many moles it is?
1 by 4.
Given weight by molar mass. So 4 by 16. So it will be 1 by 4. So 1 mole 22.4. 1 by 4 mole means 22.4 by 4. That will be 5.6 liters. Is that clear or not? Huh. So now I am giving you 80 grams of methane. So tell me fast. Occupies how much volume? 80. 5 into 22 point. Is that clear what we are doing? Always try to calculate number of moles first. Okay. So once you are calculating this number of moles, just given weight by its molar mass. Okay. So you are going to get this moles. Okay. So we know 1 mole means 22.4 liter. So 1 by 4 means just multiply this with 22.4 liter. So you are going to get 5.6 liters. Okay. So here also you are going to get number of moles are 5. So each mole, see 5 mole, I am saying 5 mole. So in the place of mole I can write 22.4, that's it. Okay. Yeah. So next, is this clear? Everything is clear? Yeah. So next thing is in 5.4 liter of O2 gas at STP has how many O2 molecules and how many, first you tell me for this, how many O2 molecules? In 5.4 liter of O2 gas at STP has how many O2 molecules?
22.4 has 6.022
Hmm.
into this 123.
So what we need to know? So first of all, you know that 22.4 liter of any gas will be having how much volume, like number of moles will be 1 mole, this is right now. So contains Avogadro number of particles like O2 molecules right now. Okay. So how much volume I given at STP?
5.4 or 5.6?
5.6, sir. Okay, we will take for 5.6 for simple calculation. So 5.6 liters means
X.
X O2 molecules. So this X we need to know. So what I should do?
X equals to
X O2 will be equals to 5.6 into Avogadro number divided by 22.4 liter. Right now this will be 4 so that you got 1 by 4 into Avogadro number. This many number of O2 molecules are there. Is that clear? If they ask for atoms,
into atomicity.
atomicity is 2. So multiply here with 2. So that will be your answer. Yeah. Okay. Next. So one last question. There. Let us move for one more concept, one more modern type. Okay. So now here, what I can give is let us say CO2 gas will take simple one. Okay, CO2 gas occupies 44.8 liter at STP. Then number of CO2 molecules are number of CO2 molecules are hmm? How much? This question. So just tell me whatever the concept you know based on that. See, occupy CO2 occupies how much volume at STP. This is mentioned now. So whenever they are mentioned STP, that should come into your mind that 1 mole of gas will occupies. So 1 mole of CO2 if I say, so what is its molar mass? 1 mole of CO2 is nothing but 44 grams. So 44 grams will occupy 22.4 liter. Okay. So now what I have given in the question, 44.8 liters are given here. So it means how many moles it is? See how many moles it is? 2 moles now? Yeah. So 2 moles of CO2 is given. Okay. So now number of molecules. So 2 into mole means how many atoms? How many particles? How many CO2 molecules? Avogadro number. So 2 into that Avogadro number, that's 6.022. Yeah, we can take, but simplest way to understand, that's why. So you got the answer. So this should be your number of moles of CO2. Okay, so if they mention it as like this also, it will be fine. Okay, fine. Next, let us move forward with few more examples. Avogadro's hypothesis we discussed now. So what we discussed there? See, at a particular temperature and pressure, equal number of molecules will occupy equal amount of volume. Okay, so that means equal volumes of all gases have equal number of molecules. Okay, not atoms, molecules we are saying at the same temperature and pressure. It means if temperature pressure is mentioned, particular temperature and pressure is specified. So at this specified temperature and pressure, yeah, so at this temperature and pressure, what I am saying? At this temperature and pressure, what we discussed? Equal volumes of all gases. Will have equal number of molecules. Okay, so for that's what we got an experimental observation is what? So 1 mole of any gas is having how much volume? 22.4 liter at STP. See, we know equal molecules they are saying. So 1 mole of a gas, any gas you take. So any gas, 1 mole of any substance will be having Avogadro number of molecules now. So Avogadro number of particles will have how much volume? 22.4 liter STP. Okay, next NTP also same thing.
22.7.
Yeah. So next here, tell me for this 5.6 liter of gas at STP weighs this much. So it can be possibly which gas? Very simple. First of all, just do what you can do. There are 4 gases are there. Okay. So now try to find 5.6 liters means what is the weight, like what is the number of moles we can get from it. At STP they are saying now. So like number of moles of that gas is equals to 5.6 given volume by 22.4 liter. So you get 1 by 4 mole of that gas you got. We don't know which gas it is, that is what the question they are asking. Now number of moles formula is what? Number of moles equals to given weight by molar mass. Okay, so now if I multiply given weight, if I multiply number of moles into molar mass, that will be equals to what? Given weight. Okay, now look at here, given weight is how much? So we got 4.25, and what about number of moles we got? So now from this I can find molar mass equals to number of moles here, 1 into 4 I can write right now. So 4.25 into 4, shall I write like this? Yes. So now what is the answer for this? If you multiply, you will get 17. What is the molar mass of that gas? 17 gram per mole you got. So which gas will be having this weight out of this 4? Which gas will be having? So how? For nitrogen it is 14, 3 into 1, so 17. So this will be how much? 12 plus 16. Okay, so 8, 28. Like this if you do, the answer is verifying or applicable only for NH3. So that will be your answer. Is that clear or not? Yes. Okay, next. Do this. Maximum number of molecules present in. So first what we need to know here, if it is 1 mole, all of them have same number of molecules. If more number of moles, more number of molecules. So just find the number of moles in all of these cases. So tell me, how can we do this? For first option you tell me. Yeah, how can I do that? Number of moles of CO2 equals to 5.6 liters by, already here we did now, 22.4 liters. So 1 by 4 moles of CO2 we have. Next for this, number of moles of CO will be 15 grams by 12 plus 16, so 28. Okay, this will be nearly half. Okay, nearly. Okay, next for this, 4 by molar mass of hydrogen is how much? H2? 2. So you got it as 2 mole. 2 by 1, 2 mole. So this will be 2 into Na. So this is 1 by 4 into Na. So this is 1 by 2 into Na. So this one 20 by, so this will be 28 plus this is 64. So how much it is? 12, 192. So 92 is very big number, now here it is very bigger number. So which is giving smaller, like a biggest number here? Like, see, 2 moles means which is having large number of molecules? 4 grams of H2. That should be your answer. Okay, let us move forward with few more questions. Yeah, look at here. Element A having molar mass 20 and element B having 30 form a compound with molecular formula A2B2. What is the molar mass? So tell me, very easy. What is the molar mass of that compound? A2B2. So what is the molar mass of this A2B2? Tell me. So how many A's are there? 2 into what is the molar mass of A? 20 plus 2 into 30. So 40 plus 60, 100 grams. So here easy only now. Yeah. If it is like AB2,
20 plus 60.
how much? 80. So 20 plus this is 30 into 2, 60. So 80. Okay, clear now? Easy only. Next, go for this question. A hydrocarbon, 3 grams of a hydrocarbon on combustion with oxygen. So hydrocarbon, let us say CXHY, on combustion with oxygen produces CO2 plus H2O. So this side reactant, this side products. Now how much hydrocarbon is given? 3 grams and oxygen 11.2 grams. Okay, so now they are asking which of this law is illustrated by this data. Okay, so now what is the mass? Here we got total 14.2 grams. This side CO2 is 8.8 grams plus 5.4 grams. This side also total mass will be 2, 1, so it will be 14.2 grams. LHS mass, RHS mass are equal. Mass of reactants and products are equal. So what I can say, it is law of conservation of mass. So first option. Okay, yes. Next, mass percentage or percentage composition. See, percentage of a element in a compound, if they ask, what you should do? Mass of that element in the compound divided by molar mass of the compound into 100. For example, I am asking, I have methane. Okay, so what is the percentage of carbon in this? So what is the formula? Mass of the element in the compound. Now I am asking for the carbon in the methane. What is the compound carbon weight? 12, okay, grams. Okay, next, molar mass of compound is 16 grams into 100. So that 3, 4, 25, so 75%. What is the mass percentage of carbon in this? Is that clear? Okay. Now I am asking similarly, what is the mass percentage of hydrogen in methane? So how do you do that? 100 minus 75 you can get. Otherwise, here what you should do? 4 hydrogen, 4 into 1 by 16 into 100. So this will be 4 times, this will be 25. So 25 will be the percentage of hydrogen. Is that clear? Okay. So formula is clear now? Yeah. So see, atomic weight of element into number of atoms. See, atomic weight of element is 1, number of atoms, hydrogen atoms in methane are 4. 4 divided by molecular weight of compound is 16 into 100. Is that clear? Okay. Next. Yeah. So we are going to discuss about stoichiometry and stoichiometric calculations. Okay. So what is this stoichiometry means? So stoichion, this stoichion means what? Elements. Metry means measure. So elements measuring. Okay. During a chemical reactions, how these elements are transformed or combining to form new set of compounds. Okay. So that is what we are going to study under this. Stoichiometry is a branch of chemistry that deals with quantitative relation between reactants and product in a balanced chemical equation. Okay, so it means quantitative means what? See, quantity, for example, I am saying A plus B gives rise to some product C plus some 2D. So now what is the quantity of this AB reacted to form this quantity of C? For example, I am saying some 50 grams of C is formed. In order to form this 50 grams of C, how much quantity of AB are combined? That depends. Okay, so that is what? Quantitative relation. Okay, stoichiometry gives us what? Quantitative relation between amount of reactants combined to form products. Okay, right. So what are the methods here we have? There are 4 different types here. First one is mass calculation. It means how much mass of reactant is taken, then how much mass of products is formed, like that. Next, mass volume calculation. Next, mole calculation, and this here mole mass also we can do, mole volume also we can do, like that. Different ways are there. Next, we need to study about this limiting reagent and excess reagent concept. Okay, next, here let me take one example. H2 plus O2 gives rise to H2O, I am saying. Okay, first of all, is it balanced equation? No. Try to balance it first. Hydrogens are okay, 1 okay, 2 hydrogen atoms, 2 hydrogen. Next, oxygens, here 2 are there, but here 1 only there. So how can I make it balanced? So either I can multiply here with 1 by 2, so that 1 by 2 into 2, how much? 1 oxygen atom here, 1 oxygen atom here. So everything is balanced, all atoms are balanced. So we can write it like this, or you can also make in a simpler manner. Just multiply this equation with 2, so that you will get 2 H2 plus 2 into 1 by 2, that will be 1 O2 gives 2, like this also you can write, right now. So what is our stoichiometry is here? These numbers are there, now these coefficients are there now for each of these reactants and products. Those are called stoichiometries. So what are those? 2, 1, 2. Okay, so this is the stoichiometric coefficients of a balanced chemical equation. Always do your calculation with respect to these numbers. Okay, it means what you can say here, 2 moles of H2 combines with 1 mole of O2 to form 2 moles of water. Okay, it means now if this is a balanced equation. These values came from where? From the equation you got. Okay, now I will be giving you to do the reaction 4 moles of H2 and 2 moles of O2. How many moles of water formed? 4 moles of H2, 2 moles of O2. How many moles of water formed? See, here if it is 2, we required 1. If it is 4, we required 2. Why it is 2? Because when we required 2 moles, half of it will be required. When I have 4, it also required half of it. Half of it is how much? 2. So 2 we have now here. So that is sufficient. So this will be giving us, see, for 2, 2, 4, 4, like that. Okay. Now I will be giving you one more question here. Okay. So tell me, I am giving you 4 moles of H2 and 4 moles of O2. How many moles of H2 is formed? Okay, just try this question now itself. The answer for this? So tell me. So for 2 moles, from the, first of all you need to look at the equation, relation with respect to the stoichiometries from the equation. For every 2 moles, how many moles of O2 is required? 1 mole. So it means for every 4 moles, how many moles of O2 is required? See, for 2 it is 1, half. For 4 it should be 2. Okay, it is just required is 2. So it means during the reaction, out of this 4, 2 moles are consumed and 2 moles are remained excess, right now. So for this reaction, how much required? Only 2 is required, but how much I given? 4. So 2 is reacted, 2 remained like excess, or I can say unreacted. Okay, this will be excess, extra thing. Okay, so how many moles of products formed? 4 moles. Okay, so after completion of reaction, so what you are going to have, tell me? 4 moles, this is 0 moles of H2, so 2 moles, this is remained extra, 2 moles unreacted, 2 moles of what? O2 unreacted, and 4 moles of H2O formed. Can we say like this? Is this clear or not? Yes. Now I am giving you one more question. Tell me, to the same reaction, I am giving you 1 mole of H2 and 2 moles of O2. How many moles of water formed? Huh? 1 na? So tell me, which one is excess, which one is limiting and all? See, try to understand. See, for 2 moles we have 2 moles. So for 2 moles how much O2 is required? For 2 moles of hydrogen, 1 mole of oxygen is required. It means I given only 1 mole of hydrogen. So for that, see, half of these moles, half of the number of moles of hydrogen is required, oxygen is required. So it means 1 mole I have given, then half of this 1 mole is 0.5 moles of water, oxygen is enough, but I have given 2. So out of these 2, 0.5 is reacted and 1.5 will be remained unreacted, and this will be 1 H2. Is this clear or not? Okay, yeah. So the one which is in excess during the reaction is called as excess reagent, and one which is in limited, see, this is completely reacting now, hydrogen here, that will be called as limiting reagent. Our calculations like amount of product formed should be always given with respect to the lesser quantity. Limiting reagent will be giving us. Okay, so now one more example I will tell you. Look at here, H2, same example only I am writing, O2, 2H2O, when 3 mole, let us make it numbers easy, 6 mole H2 and 2 mole or 2 mole O2 are given, then number of moles of H2O, water formed. Tell me how can you answer this? So is the equation is balanced first? Yes, balanced. Okay, so after balancing equation, what I told you?
Write the coefficients.
So directly we will write the coefficients here. So for 2 moles we required 1 mole, for forming 2 moles. Given, these are from equation, from this equation. Next, given
We have
6 moles, this is 2 moles. How many moles of this is formed? Now tell me, for 2 moles how many moles is required? 1 mole. For 4 moles, how many 6 moles, how many moles is required? 3. But do we have 3? No. It is lesser than our requirement. Our requirement is 3, but here it is 2. So which is less here? O2. So this is now called as limiting reagent, and our calculation should be done with respect to the one which is lesser. That is what limiting reagent. Okay. So come with this. So how can I do now? See, for 1 mole we required, for 1 mole we required 1 mole of O2, 1 mole of this limiting reagent, we require 2 moles of H2. So for 2 moles it should be 4 moles out of the 6, 4 moles is reacted, 2 moles remained excess or unreacted, we can say excess, I can say, or unreacted. Unreacted. Is this clear or not? Yes. So for each 1 mole, how many moles is forming? 2 moles. For each 2 moles, it should be 4. So product formed is 4 moles. Now what is the net resultant? Tell me. This will be 2 moles unreacted, and this will be 0 mole, 4 mole. Is this clear or not? Yes. Okay. Now till now I have given moles to moles ratio. Now question can be in the weight to weight ratio also, or moles to weight ratio also, or volume to weight ratio, like that they can give. Okay. So now let us do with some other way. Okay. So now, so see, same question I can ask you now. Same question I can ask you now. Here what I asked here, when 6 moles of H2, 2 moles of O2 are given, number of moles of water formed I have asked. Now instead of this I can ask you now, weight of H2O formed in grams. Tell me for got the answer? How much mass it is? 4. How many moles you got? Answer as. So 4 into each mole, what is the molecular weight? Molar mass is 18. So it will be 72 grams. Now what you related? Number of moles to mass. So mole to mass ratio you got now. Is this clear or not? Now I am asking one more question. So when 2 mole methane and 4 mole oxygen combined to form X mole and Y mole H2O. So tell me, what is this XY, and find limiting excess reagent so that you will get the answer. Okay. Okay, next. So right, this is also homework only. One more question also I will be giving you now. Okay, so this is one, this is second one. So you know preparation of ammonia. So tell me, what is the reaction? Haber's process. Okay, we will study that later. So N2, so 2 here and 3 here. This is the balanced equation. I myself given this balanced equation. So now you need to do when 17 grams of N2 and 6 grams of O2, 6 grams of H2 are reacted, then number of moles of ammonia formed or weight of ammonia formed. Okay, so these are the two homework questions. You can give a try and you can practice more number of questions from our modules. Okay, so you can do DPP1, DPP2 or 3, up to 3 also you can easily do. Okay, yeah. So this is about the session. If you have any doubts, we can discuss now. So now you will be having followed by physics class.